Recycling your failed 3D prints is hard. I should know. I've got buckets full of ground-up PLA and about 2 years of experience trying to turn it back into something useful. Regrind quality, contamination, moisture, any one of these can tank an entire batch. So when Plasticpreneur reached out and offered to loan me their new $4,000 desktop injection molding machine, I didn't think twice. Because injection molding is fundamentally different than 3D printing. It's less sensitive to your material quality, it's faster, and it can produce parts that FDM 3D printing just can't touch. Super nice! The question is, whether any of this actually holds up when you're feeding it contaminated 100% recycled PLA from failed 3D prints. No virgin material, no cheating. So for the last few months, I've been drinking from the fire hose of injection molding knowledge, from mold design to prototyping to creating beautiful finished parts. All to answer one simple question. Is this actually the recycling solution we've been waiting for? Let's get after it. In a perfect world, we would be turning our failed 3D prints back into, well, 3D prints. And if you've been along for the journey over the last 2 years, you'll know that we have been able to do that with a moderate amount of success. But as I see it, even when this process works well, there are still a number of problems with it. First, there's the labor issue. Shredding down your failed 3D prints is already quite a bit of work. Sifting, drying, that's even more. Then there's extrusion, which does require your attention. Not to mention, if you want high quality filament that can produce decent looking 3D prints, you need to then pelletize and re-extrude once again. With injection molding, the hope is to do half the extruding and no pelletizing, which would be a serious win on the labor side. Second, there's the quality of the regrind. The smaller extrusion screw on most desktop filament extruders is sensitive to things like larger clumps, not to mention contamination and clogging. When you're pushing the regrind through a 1.7mm nozzle, all it takes is a fleck of sawdust or a tiny aluminum shaving to clog up your entire extrusion line. So if, say, we were to instead use a process centered around a 5mm extrusion and a significantly larger extrusion screw, these issues should disappear. But the issue of clogging when it comes to filament is also compounded when you try to actually print it. Clogs on recycled filament are a major issue, especially if your work conditions are not ideal. And this, practically speaking, means that you can really only reliably print the resulting filament on a 0.8mm nozzle. And that works well, but there are still noticeable inconsistencies in the width of the filament, which leads to inferior quality 3D prints. By injection molding, though, we should be able to create a uniform finish regardless of the quality of the input. Then there's the energy consumption issue. It takes a considerable amount of energy to shred, extrude, pelletize, and then re-extrude your raw material, and that gets even worse if you have high failure rates of the 3D prints themselves due to things like clogging. Injection molding, however, really only requires one pass through the extruder to get finished parts, at least in theory, with enough practice, but more on that in a second. And finally, the elephant in the room, strength. Adding repeated rounds of extrusion does weaken the polymers. By injection molding these parts, we remove the added weakness of layer lines, which might just be able to compensate for any polymer degradation. So it all sounds good. I mean, why not just injection mold the parts? Well, up until recently, that hasn't actually been a thing that you can do in your home workshop or makerspace, at least not without building your own setup. But that's where Plasticpreneur comes in. And no, they didn't sponsor this video, have any editorial control, or even give me this machine for free, but they did loan it to me, and I think I get some kind of small commission if you use my 5% off coupon TNL at checkout. Now, for those of you who don't know about Plasticpreneur, they're an Austrian company that makes all sorts of cool products for small-scale plastic recycling. You may have seen their products being used on the Brothers Make YouTube channel if you're into recycling plastic as much as I am. What makes this product so different, though, is that it's from their new Desktop Go series, meaning it's smaller, more affordable, and more portable than any of their other products. It's also manually operated, which not only gives you a fantastic upper body workout,
wow, that's really hard.
it also saves a ton of money on motors, gears, and electronics. that doesn't mean it's cheap, mind you. 3,500 euros for this unit with a carrying case and all the tools that you're gonna need for PPE and demolding, and that's before you consider injection molds. But let's be real, that's still an order of magnitude less expensive than even small-scale industrial injection molding setups. It's also designed with safety and usability in mind. It filters the air for you as you work, it meets all the necessary EU and UK safety standards, and it is dead simple to operate. So with that, let's jump back in time and I'll show you guys how I got this thing. Once the machine is set up, you're gonna need to get yourself some injection molds. Now mind you, if you are buying this thing for educational or business purposes, you're probably just gonna choose from their assortment of ready-made injection molds, such as this carabiner design that they already sell. But come on, I mean, where's the fun in that? So more likely, you're gonna wanna get your hands on this very clever universal injection mold. Basically, this is an aluminum shell that provides a cavity which you can fill with your own custom molds. Now those could be CNC machined, they can be resin 3D printed, or, get this, you can even FDM 3D print your own mold inserts out of high temp materials. And because this is primarily a 3D printing channel, don't forget to subscribe if you're into 3D printing. In just a second, I am going to show you all the different fun experiments that I did with all sorts of exotic 3D printing filaments, as well as how that went and how many cycles each of these actually survived. But first, we actually need to design some custom molds. So let's talk about that whole process for just a second. It turns out that injection molding is a really well-developed science, and there's a lot of things that you're gonna need to know before designing your own molds. And yet, because we're dealing with pretty low pressures and pretty small injections, I actually found it pretty easy to get the gist of it. Essentially, when you design injection molds, you need to think about a handful of different things. First, and most important, is adding draft angles. In layman's terms, the parts need to slope in such a way that they will slide out of the mold rather than getting stuck. Then there's undercuts, or areas where the parts will hook onto the mold and prevent demolding. And then you have the sprue and runner design, which basically dictate how big the opening should be and how it splits and where it actually meets up with the part in the mold. And finally, you have the more advanced stuff, things like considering the shrinkage of the plastic and minimizing unnecessarily thick areas that might deform during cooling. Fortunately for us, the stakes are pretty low when you're 3D printing your own mold insert, so I did challenge myself to design and iterate on my own mold designs before having them actually CNC machined. I thought long and hard about which parts I could make that would actually be useful enough to enough people that I could make like 10 to 20 kilos of them and people still wouldn't throw the products into the trash. I eventually landed on a 1x1 Gridfinity tray, a scraper handle for a roofing blade to pull parts off of your print bed, and some smaller multi-board components. I then spent a day or two on and off between 3D printing, testing, tweaking the molds, and then finally settling on some real designs to have machined. With that said, if you're paying big bucks to actually have your designs machined out of expensive aluminum, you may just want to take advantage of plasticpreneur's mold design service, where a professional, like the very aptly named Flo, will actually help you design your part, as well as the corresponding mold for optimal flow and usability. Now those molds can have different levels of complexity and more advanced features such as overmolding for metal hardware, pins to add screw holes, or multiples of the same part all in one mold. And I mean, look at the difference between my design, this injection moldable adaptation of Gridfinity, versus Flo's take on your traditional scraper handle. This guy molds. At the end of the process, you receive a ready-to-machine step file complete with all the necessary technical drawings that you'll need to pass over to your machine shop. So now, it was time to get these bad boys machined and see what it costs. To have my own molds made, I went with PCBWay. And actually, not just because they're the sponsor of this video. Actually, I decided to shop around first, and believe it or not, their competitors actually told me that they aren't even capable of making injection molds. That's because in order to make molds like these, you need an insanely smooth surface finish on the actual cavities themselves. And it turns out that not everyone can actually do this, but PCBWay can. Plus, because they offer a very wide range of services and industrial processes, everything from PCB manufacturing to sheet metal fabrication, metal 3D printing, and even laser cutting, I had the option of actually customizing my molds even further. I decided to machine some lettering onto one of the sides of the scraper design, but then actually laser etch some very small lettering into the back of it to see if that would come through on the finished product. As always, ordering from PCBWay was honestly super simple. I just uploaded all of my designs to their website, selected the material type, finish quality, and so on, uploaded my technical drawings, and submitted it for a quote. When the quote came back, the price came out to about $559 for the Gridfinity mold and about $640 for the scraper, plus shipping and import duties, which, considering where I live in the world, added up pretty fast. So I think all in all, at the end of the day, these two molds ended up costing me something like $1,700 to my door, though PCBWay was kind enough to give me a partial credit, and they even let me use my store credit from sales of my previous designs on their platform. And on that note, if you need to have something made or manufactured, you actually can get your own $10 store credit by just adding my coupon code, which is PCBWay, the next layer 10, to your account. So thanks to PCBWay for sponsoring this video. With the order submitted to PCBWay, there was nothing left to do but wait patiently. Who am I kidding? You guys know that I had to get this thing set up, 3D print some molds, and try it out. All right, I don't have a lot of time to play around with this today, but I mean, I have to play with it a little bit, right, before we go. So I'm gonna start out with my pelletized 100% recycled material. This should be very easy for this machine. This is a very nice standardized material. Should be pretty easy to work with. I've got the machine up to 220, I believe. All right, just put that down. I'm stoked. Okay, here we go. Ready? It's going in. Here we go. Here comes the material. Smells like moldy PLA. Oh, that's a good workout. All right, we got some material. Shall we try molding? Okay, we do appear to have a good amount of moisture even in the pelletized material. It is oozing out and there's a ton of moisture coming out, but let's give it a try anyway. I don't have high hopes. I probably need to really thoroughly dehydrate the material like they said in the manual, but let's try. I don't know, do I go fast or do I go slow? Go, baby, go. All right, that seems to be it. Let's take it out and check it out. Ha. Cool. No way! First try! What? That's so cool. Oh my gosh. First attempt. Wow. Look at that. All right, now we're gonna switch to fresh regrind, good material. Put that in there. We're gonna turn this baby. And now let's take it off. See what we have inside. Oh no, it's oozing. Oh, that's why we wear glasses. So this will be our last one. Whoa, go home. Whoa. Yeah, there's a lot of moisture in there, huh? Okay, slight issue doing this with PLA, which is they're very brittle. I already broke 2 of them, but I mean, quality. Well, that's fun. It turns out that I forgot to plug my microphone in for a huge portion of the tests where I was testing with PCCF and PPACF, resin and all that different stuff. So let me just go ahead and give you the gist. I did have some success with my 3D printed molds using both the Hey Gears resin. In this case, this is the Hey Gears ultra high temp PAH270 resin that they sent over for this video, and PCCF, which was actually printed by Plasticpreneur. To my surprise though, the 3D printed molds were actually really difficult to work with, regardless of which technology I used. Okay, here are some PPS-CF molds. These ones are, should be heat resistant. All right, let's try 195 PPS-CF. Purge, scraper, here we go. Come on, baby. Let's go. All right, let's see how these PPS molds held up. Far so good. Oh man, still deforming. I think I over-injected this one, so it deformed the molds. Totally deformed the molds. We might need to print, like, solid, or more infill. Can I even demold this blob? There it is. No, we need thicker molds, but that's progress. That's some progress. I chalk this up to the fact that the surfaces are definitely not nearly as smooth as the RA 1.6 of machined aluminum, even in the case of the resin prints. Plus, with these carbon fiber filled filaments, I found it that the very necessary silicone spray just seeped into the print itself, leaving none on the actual mating surface, which then caused the parts to bond to it. I also found that unless you print with extremely thick top surfaces, like 3 to 5 millimeters thick, it doesn't actually matter if the filament is rated to withstand 200 plus degrees Celsius, because it will deform under the pressure after 1 or 2 shots, causing massive flashing. And as if all those challenges weren't enough for a beginner like me, I also did realize that neither the resin nor the carbon fiber filaments wick away the heat in the same way that the CNC machined aluminum does, which means that you're going to have to be super patient to demold or risk deforming the parts when you do. Now, I really contemplated doing a lot more experimentation on this 3D printing front, but considering that this video is really intended to be more of an introduction to what's possible, I'm gonna go ahead and hold off on that for now. With that said, I definitely do think that making your own molds is one of the more exciting and promising avenues of this entire process, so I'd be very curious to test it out again with some simpler geometries, as well as some non-carbon fiber high-temp filaments like PPS-TF. If you're interested in seeing me do that, do drop a comment down below, and maybe I'll be able to keep this machine a little bit longer so we can explore that together. And while you're down there, just make sure to subscribe so you don't miss out on any future content, because I've got another series of videos planned where I try to use this same dirty and contaminated regrind to actually 3D print furniture. It's gonna be a lot of fun. Anyways, with the 3D printed mold testing out of the way, it was time to unbox my gorgeous, professionally made aluminum molds and test them out. Here's how that went. All right, it's a new day, new month, and we have many amazing molds that we are ready to try out. So let's try them. I'm really excited about all these molds. I want to try and get some kind of flow going where I'm not purging a ton of material. I just keep going. So it's gonna be a little chaotic, and let's see what happens. All right, here goes. Whoa, clamp came off, but other than that, it might be good. Let's let that cool off in the corner. And go to the resin mold. Wow, that's really hard. Not sure why. It's harder all of a sudden. All right, let's see what we got here. Let's do our carabiner first. Perfect, beautiful carabiner. Gorgeous. Very nice. I think this is gonna have to be a 2-man job to get the most efficient workflow. Okay, I think this is our Gridfinity bin. Okay, that did not work. Gonna have to try that again. All right, let's try the universal molds. Same issue. Let's try that one again. Okay, and the exciting one, the scraper. Come on, babe. Oh, much closer to a perfect result. Very close. A little bit more oomph, and we'll have a scraper. All right, let's try this again. Plastic's cooling down, and I can't get it all the way in. That's what I think is happening. It's a good workout. That is hard. Whew. Let me get these open. See what's inside. Oh, super nice. We have a scraper. There are some minor imperfections around the screws, but we have a scraper. Oh yeah, dude. It's an oily scraper, but it's a scraper. Dope. All right, CNC Gridfinity. Here it goes. So close. We're getting closer every time. So close. Look at that. Pumping up the temperature. So we're at 210 Celsius. Let's see what happens with the 2 bolts. Hopefully no flashing. Go, baby, go, 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 go. Go all the way in. Oh, wow, it's so much easier when it's hot like that. I think that may be all the way through. It's getting so hot in here. This is a 2-man job if ever I saw one. It's still really easy. I think that's a good thing. Now it's filling up. That's full. Yes, it's a Gridfinity bin. It's a red Gridfinity bin. Am I gonna be able to demold it without breaking it? Look at that. The world's first injection molded Gridfinity bin. How are we gonna get it out? I don't yet know, but it's there and it is nice. Ha! Look at that! Injection molded scraper, baby! 100% recycled PLA. Beautiful. Oh man, let's make some more? Hell yeah, dude. With a little bit of experience under my belt then, it was time to call in the reinforcements from Jacques and Daniel and see how quick and efficient we could get this process going with 3 sets of hands. After all, working alone, I was losing like 50% of my material to oozing, and the material that I was using was spending way too much time sitting in the hot extruder. Now, truth be told, even with 2 people fully focused on demolding and reassembling the molds, we still couldn't keep up with the sheer speed of the injection molding process. So I think that if you really wanted to optimize for production efficiency and profitability, you'd want to have like half a dozen molds at your disposal, and then 4 or 5 people constantly working on mounting, disassembling, demolding, and reassembling them, while one person just keeps that crank turning. But at that point, you might even want to upgrade to the more production scale machines that Plasticpreneur offers. But if you wanted to maximize your return on this machine, I guess you'd probably want to use some kind of low cost or even free labor. A labor force that wouldn't mind the hot, sweaty Oh, jeez. I just reinvented the sweatshop, didn't I? In any case, with enough molds and enough helping hands, I could easily see how you could recoup your investment in a machine like this. Provided, of course, that the end product was actually high value enough to sell for a few bucks, because I honestly don't think that anyone is gonna spend like $5 on a plastic carabiner. But again, I have to admit that it's pretty clear that the target market for this particular machine is going to be education and maker spaces, not people trying to set up a plastic recycling business. But now, the moment you've all been waiting for, let's have a look at the results. Pretty epic, right? Honestly, I'm super pleased with how these parts turned out, and I just cannot wait to take my entire bin of contaminated regrind and give it a new life. I also can't wait to see some of you guys at some future 3D printing events so I can actually give these out to all of you. Truth be told, I was planning to surprise my Patreon supporters with some of this stuff, but have you seen how expensive it is to ship a simple padded envelope these days? What? I would honestly lose my shirt. So, at the beginning of the video, I posed the question, could injection molding be the solution for our 3D print recycling woes? And honestly, I think it might be. Now don't get me wrong, compared to some of the filament recycling solutions now coming out on the market, this is a much more expensive alternative. And that's before you even consider the type of powerful shredder that you're gonna need to grind up things like failed 3D prints or failed injections, or all the oozed plastic. But if you figure in the value of labor and the cost of all the various headaches from things like clogging nozzles when you actually print recycled filament, I think that this just might be a much more robust, practical solution for recycling 3D print waste. Is it the easiest, cheapest, or most accessible? No. Have I mastered the process and gotten it to the point where I can reliably 3D print my own molds and create usable parts out of them? Not yet. And do I think that every one of us will one day have a home injection molding setup sitting next to our 3D printer? Definitely not. But for schools, maker spaces, or enterprising folks who are interested in the business of plastic recycling, there's no denying the appeal of being able to very quickly turn contaminated waste into beautiful, finished products. Personally, I'm going to be running a whole lot more plastic through this thing while I still have it, rather than trying to go through all the hassle and labor of trying to make high-quality filament from that plastic. And in case you're not sure what I'm talking about with the hassle thing, I'll refer you to this latest video in my filament recycling series, where I detailed each of the various hassles, hurdles, inefficiencies, and headaches that you'll have to face if you want to turn your own plastic waste into usable filament. Oh, also, don't forget to subscribe, because apparently over 70% of you haven't, and this is embarrassing, but I really enjoyed hanging out with you today, and I'd love it if you stopped by again soon. That's all for this week, but I'll see all of you on the next layer.